Alright, so this is section 2.5. It's a word problem section, but I think each of the word problems is essentially a clone from chapter 1. So you've done these word problems already, so there isn't anything new. And they're a little bit easier in chapter 2 because when we have to take the derivative, I can use the shortcuts, where these word problems, when we did them in chapter 1, we had to use limits to do the derivative. Ultimately, we just have to understand how the function works and what the derivative means. As much as anything, each of these problems is just giving me a function. I have to understand what the x's stand for and what I get out when I plug in a number for x, what the derivative stands for and when I get out when I plug a number in for the derivative. And there really is really limited algebra, so hopefully these aren't bad. So in problem 2, I can't fit 1 and 2 up on the screen at the same time. I'll bring problem 1 back on the screen for you, but this is a problem 1 that you're going to be able to do after I do problem 2 if you can't do it already. So as I read through problem 2, the cost function for producing x units of a certain product is. So how this function works, the x stands for the number of units of the product that I'm producing. And when I plug a number in for x, I get out the cost of producing that many units. So C parentheses x means the cost of producing x units equals that. I'm going to exploit my calculator a lot in this section. And I'll do the first couple problems 2 ways on my calculator. And then ultimately, I'll do them all kind of one way, kind of the more efficient way. So 2a says find the cost of producing 4 units of the product. Well, that's just a matter of plugging 4 in for the cost function. I don't need a derivative to find out the cost of producing 4 units. The cost function does that without a derivative. So this is exactly how the cost function works. If you plug a number in for x in the cost function, it's going to give you the cost of producing that many units. I can't really do this so well in my head. I wouldn't want to. So I'm going to do this on my calculator 2 ways. So ultimately my answer should look like that. If I just wrote a number down, I'd be content with it. And to get that number, I can do it from the main screen on my calculator. So on the main screen of my calculator, I can just go 0.4 parentheses 4 squared plus 7 parentheses 4 plus 8. And I get $42.40. Which is completely fine, and that wasn't particularly hard to do. In some of the problems, it's going to be a mess to plug the number in that we need to plug in. The more efficient way to handle 2a, not so much for this problem, but when it gets hard to enter the part A's on my calculator, is to use the y equal feature on my calculator. So what I'm going to do is use the y equal feature. I'm going to enter the function that's given, so 0.4 x squared plus 7x plus 8, and I'm going to set a window in it so that it handles the number of units that I need to worry about. So as long as my window has an x max bigger than 4, I'll be able to use my calculator to generate this answer, whether I can or can't see the graph. And for this one, if I just hit zoom standard, it's going to set a window that's perfectly fine to get this number of $42.40, even though I can't see much of the graph. So the window I have is that window. And on my calculator, to use the graph to get the answer of plugging 4 into the original function, I hit the second button, the trace key, and then select option 1 that says value, hit enter on value, and then type the number 4. And when I do that, it plugs the number in and gives me that same $42.40. Again, I just hit second in trace, hit enter on number 1, type number 4 and hit equals, plugs the number in for me. And that's how I'm going to do most of the problems, especially when they get grungy to do. That's part A. Part B says create the marginal cost function C prime of x. The derivative of a cost function is called the marginal cost function. And what a marginal cost function estimates is the cost of producing the next unit. So when I do, let me do C prime of x real quick. C prime is very easy to calculate. I'm going to use the just the general power rule to do C prime of x. So I'm going to go 2 times 0.4 to the x to the first power. And then the derivative of 7x is just 7. The derivative of 8 is just 0. So I just have to do 2 times 0.04, which is 0.8. So that's the derivative. And then what a marginal cost function does is it estimates the cost of producing the next unit. So this is a marginal cost function, and it can be used to estimate the cost of producing, I'll say, the next unit of the product. And that's all there was to do for part B, is to find the derivative. Part C says find the marginal cost when 4 units are produced. Part D says interpret the answer. Interpreting the marginal cost when 4 units are produced, the answer that I get to part C is going to be what the cost of producing the 5th unit is going to be. So for part D, I'll say the cost to produce the 5th unit will be, it's going to be some dollar amount. There's going to be 2 ways I can get that number. I can get it from the main screen, or I can get it from the graph screen. First I'll get it from the main screen, then I'll get it from the graph screen. It's easier to get it from the graph screen when the functions are ugly. So to do part C, find the marginal cost when 4 units are produced. I'm going to use the marginal cost function and plug 4 in for x. So I'm going to get C prime of 4 equals, and this is going to be my answer to part C. So I'm going to go second quit, 0.8 times 4 plus 7. I'll get $10.20. And so I probably could put a dollar sign there because it's money. And then I can simultaneously answer part D. Part D, the cost to produce the 5th unit will be $10.20, because the marginal cost gives you the cost of producing the next unit. Since I'm finding the marginal cost when production level is 4 units, it's the cost of producing the 5th unit. I'm done, but the nicer way to, well, another way to do part C would have been to go to the graph screen. I don't have to graph the derivative. All I have in my y equals is the original function. And I have some graph that I can't see much of the graph, but it's okay because my window has 4s in the range of my x min and x max. Now if I just go second in calc, go down to option 6, which is dy dx, and hit enter. Now if I type the number 4 and hit enter, what it's going to do is going to plug 4 into the derivative. And I get that exact same $10.20. It's probably going to be easier to do plugging numbers into the original function and plugging numbers into the derivative using the y equals feature, because you only have to enter the function once, and then you don't, it's going to be easier. Or you could do both on the main screen. That's just I prefer using the y equals and the value in the y equals dy dx to get my answers for plugging numbers into the function and plugging numbers into the derivative, but you don't have to. So that's the end of problem 2. Your problem 1 should have exactly the same feel as my problem 2. So pause the video, give it a try, check out your answers. And if you're doing your calculator, when you go to do your calculator, because I'm finding the cost of producing 100 units and the marginal cost of producing 100 units, it doesn't matter exactly what the window is, but your x min and your x max have to contain 100. So the x min was already set at -10. My x max has to be bigger than 100. 101 would be big enough, but 150 would be also fine. And then it wouldn't matter what your y's are. You can use your calculator to find the cost of producing 100 units from the graph screen and the marginal cost of producing 100 units from the graph screen. And that's what I would suggest doing, but you don't have to. So, similar problem. This problem right here, I'll just read through it. From past data analysis, a manufacturing company finds the cost of manufacturing for a certain product can be modeled by this horrible function where x is the number of units produced and c of x is the cost in dollars. So it's exactly the same kind of function. X is the number of units produced, c of x is the cost to produce that many units. And the questions come in a little bit different order, but I can live with that. Part A says create a marginal cost function, which marginal cost is always just a derivative of a cost function. So I'll do this derivative. So I'm going to go c prime of x equals, the derivative of 3,000 is 0. Don't have to worry about it. For 10x squared, its derivative, I'll go 10 times 2 is 20. Lower the exponent to the x to the first power. To do the derivative of the minus 7 square root of x, I have to think of it as minus 7x to the 1/2. Then I'm going to go 1/2 times minus 7 times x to the 1/2 minus 2/2. That's going to be minus 7/2 x to the negative 1/2, which is minus 7 over 2x to the 1/2, which is minus 7 over the square root of x. So I'm going to get minus 7 over 2 square root of x for the derivative of that piece, because I take the exponent 1/2 and multiply it by negative 7. That gives me a negative 7/2. Lower the exponent by 1. 1/2 minus 1 is the same as 1/2 minus 2/2. That gives me an exponent of negative 1/2. I make the negative exponent positive by moving it down to the denominator, and then I'm left with a 1/2 exponent, which I write as a square root. To do this derivative, 3x to the 5/2 power, I'm going to go 5/2 times 3, and I'll take x to the 5/2 minus 2/2. 5/2 times 3 is 15/2. And my exponent would be x to the 3/2. It would be okay if I would have written this piece as 15/2 times the square root of x cubed, because the 2 turns into a square root and the x cubed would go under. Both of those would be okay. So I'm done with the derivative. I have kind of two versions of the derivative. So I could say for part A, I could either write c prime of x equals 20x minus 7 over 2x to the 1/2 plus 15/2 x to the 3/2. Or I can do c prime of x equals 20x minus 7 over 2 square root of x plus 15/2 times the square root of x cubed. There are both correct derivatives. I should probably be consistent, as this is weird to have a square root and then a fraction exponent. Either have fraction exponents or have radical symbols, but both seems kind of odd. So I'm done with part A. Part B wants me to evaluate and interpret c of 36. I'm not using the derivative, I'm just using the cost function, so it's going to give me the cost of producing 36 units. I can do c of 36 from my main screen. To do it from my main screen, I'd have to go 3,000 plus 10 times 36 squared minus 7 times the square root of 36 plus 3 times 36 to the 5/2 power. So from the main screen, I would do this. Let me just do that real quickly. So clear 3,000 plus 10 times 36 squared minus 7 second square root of 36 plus 3 parentheses 36 exponent parentheses 5 divided by 2. And I get $39,246. And again, I don't like using the main screen to plug in numbers to a function. I think the more efficient way to do it would go y equals, enter the original function, 3,000 plus 10x squared minus 7 square root of x plus 3x up arrow parentheses 5 divided by 2. Create a window, so my x has 36 in it, so if I look at my window, my x needs to be bumped up past 36. 40 contains 36. I don't care about the rest of the window, and I really care what the graph looks like. And now I can just go second calc, hit enter on value, type in 36, and I get that same 39,246. So it's much more efficient, I think, entering the function in the y1 and using the value operation to get the y values. So I've evaluated for part B, but I haven't interpreted. And the interpret is just the cost of producing 36 units is that number. For part B, evaluate and interpret C prime of 36. Well, the interpret is the cost of producing the 37th unit is and there's two ways to do it. One way is to go from the main screen and go C prime of 36 and then use one of these two functions. It's going to be 20 times 36 minus 7 over 2 times the square root of 36 plus 15 over 2 times the square root of 36 cubed. I don't care to enter that. That's going to be a disaster for me to enter. I'm going to try to do it, but I'm probably going to mess it up. But I'll give this a try. So I'm going to go main screen, 3,000 plus 10 parentheses 36 squared minus 7 second square root 36 plus 3 parentheses 36 exponent parentheses 5 divided by 2. I did that fast because I don't want you using this feature. Oh, I just plugged it into the original function. Idiot. Did I? Did I plug, oh, I did plug that into the original function. I should be plugging it into the, I should be looking at this line that I covered up. I should have been going 20 parentheses 36 minus parentheses 7 divided by 2 times, oh boy, I'm afraid. Oh gosh, I'm afraid I'm not even exactly, this calculator is really nasty when it comes to doing fractions like this. So it's 7, that's why I don't like doing this, 7 divided by parentheses 2 second square root of 36. The whole denominator needs to be in a parentheses, plus parentheses 15 divided by 2 times second square root of 36 up arrow 3. And I get 709, if I did it right, 719.99. I get $720, so that would round up. Let me do this one more time because I'm afraid I did it wrong. So 20 parentheses 36 minus 7 divided by parentheses 2 second square root of 36. Parentheses, probably needed 2 parentheses, plus parentheses 15 divided by 2 times second square root 36 up arrow 3. Oh, I got a different number. because I think I forgot a parentheses. So entering from the main screen, the complicated functions is super complicated. The better way to do plugging a number into the derivative is get your y equals in there, get a graph, and then do second calc, go down to option 6, dy dx, type the number 36 in because I'm looking for 36 units. And this was the correct one. The first one I forgot a parentheses. So I don't like using the main screen to evaluate the original functions or the derivatives. Once the functions start getting complicated, it's just so hard to do from the main screen, but so easy to do from the graphing screen. It's not that hard to enter the original function. You don't have to enter the derivative at all. So when I use my calculator, I have two choices. I can stumble through the main screen, or I can use my derivative to do the evaluations of both the original function and the derivative. I'm going to use the graphing screen from now on to get these values because it's so much more accurate. All right, so that's the end. So I took the derivative, and that's all I'm going to do. I'm not going to do anything with the derivative. I'm going to enter the function and my y1. When I plug a value into the function, I use the value feature, and that gives me the cost of producing that many units. I'm going to use the y1 and the dy dx feature to find the marginal cost, and that's going to be the cost of producing the next unit. In this case, the 37th unit is going to cost $2,339.42 to produce. So you get to do problem 3. And then I'll move on and do problem 6. 6 is another cost function. In this case, the function that's given in problem 6 is a cost function, and the x stands for the cost of producing x pairs of socks. So I'm going to do exactly the same for problem 6 that I did for problem 4. I'm going to find the marginal cost function, and then for the evaluate and interpret parts, I'm going to use my calculator rather than the main screen. So the marginal cost is a derivative of a cost function. To do the derivative of an ln, you need a fraction. So generally, if I was trying to do this derivative, because this is a multiplication, this is 3 times the ln of x squared plus 2. Technically, because this is a multiplication, I should use the product rule. So if I'm doing c prime of x, I'm going to do the derivative of the first factor, which is 3, times the ln of x, the squared should be in the parentheses, plus the derivative of the ln of x squared times the 3, and then the derivative of 2 is just 0, so I won't need to worry about it. When I continue this, the derivative of 3 is 0, so I get 0 times the ln of x squared, and I really insist on having the exponent where it probably shouldn't be. To do the derivative of that ln, you create a fraction. In the denominator, you put the argument of the fraction, which is x squared, and in the numerator, you put the derivative of that x squared, which is 2x. So this is going to give me c prime of x. This piece comes out to 0 because anything times 0 is 0. And for this piece, I get plus, and I have to reduce a little bit. This x is going to completely cancel, and it's going to cancel that down to an x to the first. So I get 0 plus 2 over x times 3, and then I'm going to multiply that 2 and the 3, and I'm going to get c prime of x equals 6 over x. That I can actually use the main screen to do my derivatives if I care to, because that's easy to work with. So my answer to part A is c prime of x equals 6 over x. So I have the original function, I have my derivative, I can get my answers, the y answers to part B and part C using the main screen, or I can use my y equals. I'll do it both ways because this is easy both ways. So the first thing I need to do is c of 10, which is going to be 3 times the natural log of 10 squared plus 2. And what that's going to give me is the cost to produce 10 pairs of socks. I'll do this from the main screen because I could actually do that, but I prefer doing it from the graph screen. But when it's not hard, the main screen's, you can do it. So I can go 3 ln 10 squared plus 2, and I get $15. I'm going to round that to 82 cents. Put a dollar sign. So the total cost to produce 10 pairs of socks is $15.82. And again, I feel good about going to the y equals screen, putting the original function 3 ln of x squared plus 2 in it, setting my window up so that at least the x max is bigger than 10. My x max is 40, which is bigger than 10. I don't need to reset it. It's going to sketch a graph. I don't care much about what I see. I'm going to go second calc value and type in the number 10, and it gives me exactly that 1582. So I'm done with part B, and I've kind of even confirmed my answer because I got the same y from both screens. Now I'm going to go on to part C, evaluate and interpret C prime. This header came over from another screen. It doesn't need to be there. It should just say evaluate and interpret C prime of 10. Well, C prime of 10 would equal 6 over 10, which is 0.6. That's just plugging something into the derivative. And so I'm going to say the cost to produce the 11th unit, 0.60 is 60 cents, which is ours $0.60. So 0.60 is 60 cents, or $0.60. And then from my main screen, I would just, that I did in my head. From my graphing screen, I'd go second calc, go down to option 6, dy dx, type in the number 10 and hit enters, and you get exactly that same 0.6. So when it's easy, it doesn't matter if I do it in my head or I use the main screen. When it's a grungy function, using my y equals is way superior than using, the main screen, because the main screen can get really, really tricky to enter the functions correctly. All right, so that's the end of that, and you can try to do number 5. So pause the video, give it a go. And then the next problems, they're no longer cost functions, but it's basically not anything new. So the difference between the first 6 problems and the next problem is the function now isn't a cost function. So the radio corporation determines the weekly profit P of X from selling X radios can be modeled by. And it gives me a function. The X stands for the number of radios that are sold, and P means profit. So that's how much money they're going to make. Not the cost of producing, but how much profit they're going to make when they sell that many radios. And this little parenthetical comment says this function can be used to model the profit from selling 0 to 1,000 radios, but once we go over 1,000 radios, this function wouldn't be appropriate. It might not give quite the right number. So, first part, determine P prime of X. That's just the derivative. So P prime of X is going to be 2 times negative 0.01, lower the exponent to 1. So that's going to be negative 0.02x. The derivative of 12x is just 12, so that's a plus 12. And the derivative of minus 2,000 is 0. I'm done with part A. That's the derivative. Part B, evaluate and interpret P of 500. I can do it from the main screen. P of 500 is going to be negative 0.01 times 500 squared plus 12 times 500 minus 2,000. And that's going to give me the profit from selling 500 radios. So whether I do it from the main screen, from the graph screen, I should get the same answer. I'll do both because this isn't hard. So my answer to part B, the profit from selling 500 radios, is going to be whatever that comes out to be. So second quit, main screen, negative 0.01 times 500 squared plus 12 times 500 minus 2,000 minus, I get $1,500. assuming I entered it right. So negative, that looks right. Let me do it from the graph screen. So I'm going to go y equals, put that function in there, negative 0.01 x squared plus 12x minus 2000. My window has to have an x max bigger than 500. So I'm going to set my x max up to like 550. And again, I'm not going to see any of the graph, or at least I'm not expecting to see much of the graph. It doesn't matter. And now I'm going to go second, calc, value, type in 500, and I get that same $1,500. So that part is done. Move on to part B, C should I say, evaluate, interpret P prime of 500. Well, P prime of 500 is going to be negative 0.02 times 500 plus 12. I can do that from the main screen, or I can do it from the graph screen. From the main screen, I would just go second quit, clear, negative 0.02 times 500 plus 12, and I'd get 2. Interesting. And from the graph screen, to make sure that's the same case, I'd go y equals, that's in there. I go second calc, dy dx, and I type the number 500 in, and it gives me that same number 2. So that's nice. When they match up like that, you know you haven't made a mistake. And so now I'm going to say, so the marginal profit, which is the derivative of the profit function, it gives you the profit for selling the next unit. So the profit from selling the 501st, in this case radio, will be, and they're in dollars, so $2. So it's exactly the same as the first group of problems, other than instead of I have the word profit in place of the word cost. The derivative of a profit function is a marginal profit function, just like the derivative of a cost function is a marginal cost function. A marginal profit function gives you the profit from selling the next unit as opposed to the cost from producing the next unit. I'll flash number 7 up on the screen so you can give it a go. And then I'll move on and do number 10. 10's exactly the same except a grungier function. So a telemarketing company has determined that the monthly profit P of X from selling X magazines can be given by this function. So this function, X stands for the number of magazines that they sell, P of X is the profit in dollars, and this only works for selling up to 100 magazines. Once we get over 100 magazine subscriptions, not magazines, magazine subscriptions, this function doesn't give you the right number. It's not as accurate. So part A, determine P prime of X. Well, the derivative of 5x is just 5. The derivative of the square root of x, you have to write it as x to the 1/2 power. The derivative, you go 1/2 x to the 1/2 minus 2/2, which is 1/2 x to the minus 1/2, which is 1 over 2x to the 1/2. So it's going to be 1 over the square root of x, 1 over 2 square root of x. So there's the marginal profit function. Derivative of 5x is just 5. The derivative of square root of x is 1 over 2 square root of x. Part A, do evaluate P of 20. I'll use the profit function and go P of 20 equals 5 times 20 plus the square root of 20. And then the answer is going to be the profit from selling 20, I'll just say subscriptions because I'm not going to have the room to write magazines. And I'm going to round to two decimal places because it's money. So I can do that from the front screen. So I can go second quit, clear 5 parentheses 20 plus second square root of 20, and I get $104.47. I could have went to the y equals screen, took this original function, 5x plus second square root of x, graphed it, I don't care, the window was big enough, it's fine, and then I go second, calc, value, type in 20, and you get that same $104.47. Part C, evaluate and interpret p prime of 20. One way to do p prime of 20 is just to use the main screen and go 5 plus 1 over 2 square root of 20. That's tricky. I'm going to need parentheses to do that. From the main screen, I'd go second quit, 5 plus 1 divided by parentheses, 2 second square root of 20, parentheses, parentheses. And I'd get $5.11. I'll talk about that in a second. From the graph screen, I could have did second calc, went down to dy dx, typed in 20. I'll get exactly that same number. So they're consistent with each other. For me, it's easier to use the y equals screen. So I've finished problem C in terms of the number, and then in the interpret is the profit from selling the 21st subscription is $5.11. All right, so your problem 10 and my problem 10 and your problem 9 should be about the same. So give it a go, and I'll move on and do number 12. It's a little bit different function in number 12, but it's basically the same. The last problem is the one that's a little bit of a twist. So if I read through number 12, the number of dollars spent on advertising a product influences the number of items of the product that will be purchased by customers. The number of diamond rings that will be purchased by customers is a function of the amount spent on advertising and can be modeled by where X represents the number of thousands of dollars spent on advertising. Sorry for that horrible read. Apparently I need to go back to the 4th grade where I got a D in reading. Imagine that. So anyways, this function, what the X stands for, the X is the number, how much money in thousands of dollars that I spend on advertising. And what this function gives me out as a result is the number of diamond rings a customer will purchase. So the X stands for the amount spent on advertising in thousands of dollars, and what I get out, the N of X, N meaning number, is the number of diamond rings. So first find the derivative, N prime of X. The derivative of 150 is 0. To do the derivative of minus 200 over X, I have to move the X up to the numerator and make it minus 200X to the negative 1. And then I'll just use the general power rule. I'm going to go negative 1 times negative 200, lower the exponent by 1, I'll get positive 200 x to the negative 2, which is positive 200 over x squared. So that's my derivative. Now it's just interpreting. To do n of 5 is going to be the number of diamond rings sold when we spend $5,000, because X is a number of thousands of dollars spent on advertising. That's going to be $5,000. I'll plug the number in. I'm going to go 150 minus 200 over 5. So from the main screen, if I did that, 150 minus 200 over 5, I'd get 110 rings. Let me do that from the graph screen. So I'm going to go to the y equals, clear this out, and go 150 minus 200 divided by x. As long as my window has 5 in it, it's going to be a fine window. Now I do second calc value, type in the number 5, and it gives me the same 110 rings. So the answer to part B is when 5,000 is spent on advertising, $110 rings will be sold. For C, find and interpret n prime of 5. To do n prime of 5, I can go n prime of 5 equals 200 over 5 squared, which from the main screen, second quit, 200 divided by 5 squared is 8. From the derivative, second calc, dy dx, type in 5, and you get the same number 8, although it needs to be rounded because my calculator doesn't really do calculus. It does some sort of estimating method. So main screen, you get the 8. The derivatives, the graphing screen, you get the 8. And what that's going to give me, the 8 stands for the number of rings that you're going to sell. And when you spend the next, and what n prime, well, next number would be 6. And 6 stands for $6,000 of advertising, or when the next when my advertising goes up from 5,000 to 6,000, when I spend the next $1,000 on advertising, I'm going to sell an extra 8 rings. So I'll say that when the next $1,000 is spent on advertising, 8 more rings will be sold. Because kind of it tells me the 6, what happens when I have the 6. In this case, the 6 stands for $6,000 of advertising compared to $5,000 of advertising, which is an extra $1,000 worth of advertising. All right, so that's 11. I don't know if that was the best 11 ever, but it kind of is done. And the beautiful thing about 11 is the algebra is exactly the same. The interpretation is pretty darn close to the same. I just changed my function of advertising dollars, figuring out how many diamond rings I'm going to sell, to advertising dollars to selling Eddie Van Halen guitars. And when you get into parts A, B, and C, you'll see the functions exactly the same. So the interpretations might be subtly different because I'm not selling rings, I'm selling guitars, but the algebra is going to be exactly the same. The last 2 problems won't make their way onto this test at all, but at some point we're going to need this. I think it's in chapter 3 somewhere that these kinds of problems come back, and we need to understand this concept. And this is the concept, the new kind of thing, the really only new thing in this section is in problems 13 and 14. And again, they're just kind of laying the groundwork for the next chapter. And as I read problem 14, it tells me a Boy Scout troop builds Pinewood Derby cars. They have found the price to sell, I suppose. This is what I'm trying. They're building and selling Pinewood Derby cars because some kids want to have these Pinewood Derby cars. They have found the price demand function as P of x equals negative 0.5x plus 25, where x is the number of Pinewood Derby cars demanded and P of x represents the price. So what happens is if I put a number in the equation for x, that's how many Pinewood Derby cars I'm going to sell at that price. The algebra is going to produce the price that I need to charge to sell that many Pinewood Derby cars. And the first part of this says evaluate and interpret P of 10. The 10 stands for x. It's the number of Pinewood Derby cars. The P of 10 represents the price. So when I do P of 10 equals negative 0.50 times 10 plus 25, what it's going to give me is what I'd have to sell the Pinewood Derby cars for to if I wanted to sell 10 of them. So I'm going to go negative 0.50 times 10 plus 25, and it gives me 20. So what this says is at a price of $20, 10 cars would be sold. based on this price demand function. Of course, if you'd raise the price, the number of cars that you would sell would go down. If you'd lower the price, the number of cars that you'd sell would go up. So so the price demand functions they're more realistic than some functions, because clearly demand is a function of price, and that's what this shows. So that's part A. That's just to get you exposed to a price demand function. Again, they'll come up, not in our test in this chapter, but later in the semester they'll come up. The next part of problem 14 says to create a revenue function. Generally, for these Pinewood Derby cars, how much money the pack is going to make is the number of cars times the price per car. And the number of cars stands for X. The price per car is the P of X function. So the revenue function is the number of cars times the price per car. They sold, 20 cars at $10 each. Well, they'd make $200. You'd go 10 cars times $20. You'd get a revenue of $200. So a revenue function is the number of units that you sell, X, times the price per unit, which is P of X. So my revenue function, it even tells you to do that, just multiply X times P of X. So the answer to part B, the revenue function is going to be, when I clear this parentheses, I'm going to multiply those X's and get negative 0.50 X squared. And then I'm going to multiply that X by that 25 and get plus 25X. So that's a revenue function. So that's going to give me how much revenue we're going to generate for selling X Pinewood Derby cars. And then the derivative of the revenue function is a marginal revenue function, and that's going to give me the amount of revenue I'd get by selling the next car. So I'm going to take the derivative of this because I'm told to. I'm going to go 2 times negative 0.5, which is negative 1. Lower the exponent by 1 to x to the first. The derivative of 25x is just 25. So that's my marginal revenue function. That's my revenue function. Part D, evaluate and interpret R of 10. To do R of 10, I'm going to plug 10 into the revenue function. So I'm going to go negative 0.50 times 10 squared plus 25 times 10. And that's going to be the amount of revenue for selling 10 Pinewood Derby cars. So let me do this on the main screen, and I'll do it on my graph screen. So on the main screen, I go negative 0.50 times 10 squared plus 25 times 10, and I get 200. From the y equals screen, I go y equals, put the revenue function in there, and the revenue function is negative 0.50 x squared plus 25x. Graph it, don't care what the graph looks like. Do second calc, 1 for value, and then type in 10. And you get that same $200. And I knew that was going to be the case, that because at a price of $20, 10 cars would be sold. The revenue from selling 10 cars requires a price of $20. 10 times 20 is 200. And the interpretation of this is the revenue that the troupe will earn from selling 20 cars is $200. For part E, evaluate, interpret R prime of 10. That's going to be the revenue from selling the 11th car. So the revenue from selling the 11th car, that's what I get when I plug 10 into the derivative. So R prime of x is negative 1x plus 25. So I'd go R prime of 10 is negative 1 times 10 plus 25. That I could do in my head. That's negative 10 plus 25, which is 15 bucks. So in order to bump their sales up, they're going to have to lower the price of the cars. Let me get that from my graph screen as well. So I'm going to go to my graph screen, do second calc, go down to dy dx, type in 10, and I get that same $15. Same interpretation. The revenue derivative of a revenue function is called a marginal revenue function, and marginals estimate the next. In this case, the R prime of 10 is the next would be the 11th car. So that's that problem. And again, this one's not incredibly important. I just want you to see a price demand function because they're going to come up again, and I didn't want it to be brand new when we see it in another chapter when it's test worthy. I want it to kind of settle in for a little bit. So you just have to get done now with problem 13, and that will be the end of this section, and then we'll be ready for the review after this. This is the last bit of new material for chapter 2. And I'll do the review next, and if you can do every problem on the review, you should be spot on ready for the test.